Okay. So now we have this these movements, and if I show these on this I section, let's say this is my I section on which I have to show my final answers. My my, as I can see from here, is acting in the negative y direction. So this is my my of minus 84, and my mz is also acting in the negative z direction. So this is my mz. Now these two values are the values of loads or the maximum bending moments which are produced by the combined effect of two loads. One that was acting inclined to over here, and the other one that was inclined on that side. Okay, so now I have the load, and the resultant of these two loads will simply be somewhere here. And let's say this, I will name it as 1. And what is the inclination of this resultant load?
सर ये -182 है तो ये
45.
दूसरी साइड पे नहीं होगा?
On which side?
सर -182 z एक्सिस पर.
So it is in the negative y direction, a negative z direction. This is the positive z direction on this. Okay. So let's say now my inclination of the neutral axis, I will assume firstly its direction like this one. This is my neutral axis or the final neutral axis due to the combined effect of everything. And let's say I will assume its direction somewhat like this one. And I have to use the formulation that we derived yesterday, that is this one. Iz over Iy tan of theta. Okay. So I have this inclination of the neutral axis. Now this angle beta is this angle with the angle of neutral axis with the horizontal that we need to calculate, and this inclination or this theta is this inclination. Now can anyone tell me what is this angle theta?
65.26.
65.26, or let's say I will calculate the tan theta as a whole. So tan theta will be
Can you show the values of Iz and Iy?
minus 182.34. What is this value? What is this value, anyone? Is this
सर आई तो वो नहीं होता
what?
आई तो वो
ये
नहीं
तो
होता
मूवमेंट नहीं ले रहे आप.
So yesterday we did one derivation. Let me show you again. This one. Okay.
जी
So
सर
in
तो
this
आई तो
in this one we simplified this formula and we got this answer, this final answer, that this angle or this tan beta will be equal to Ix over Iy tan of
बोल
theta.
रही हूँ ये आई है ना आई तो वो आप तो वो पुट कर रहे हैं मोमेंट पुट कर रहे हैं.
No, I'm not putting on the moment. I'm
आप
just
मूवमेंट
putting on
आई और आई तो क्वेश्चन में नहीं दिया हुआ.
I is given in the question. I am calculating first this tan theta, this angle tan theta. Okay. So what is this theta? Theta is the angle of the resultant moment, right? So if you see in this figure, this angle theta, I am not calculating tan beta yet. I am just calculating this angle theta. I don't know this theta as well. What is this theta?
24.2.
Yeah, 24, or I mean to say that this theta is like tan theta is this y axis over this x axis or this z axis. Do you get my point?
Yes, sir.
Okay. So now this tan beta, what is Iz? What was the value in question? I think it was 112.6, and the value in the y direction is 18.7, and this tan theta is equal to 0.4067, right? So this tan beta, or can anyone give me this value of beta?
67.78.
67.78. Are you sure about that?
Yes.
Because I have this answer.
It's 70.17.
Yeah, 70.2 degrees. Okay, so this is my angle beta, and you can see, like I told you yesterday, if the sign comes out to be positive one, that will mean that the orientation that we have assumed, that is basically clockwise direction from the horizontal axis, is correct. So this is the orientation of my neutral axis in this case, or the axis at which the bending stresses or all type of bending stresses will be zero. So this was the first part of our question. Okay. So any confusion up till this
एंगल
point?
कैसे नेगेटिव आ सकता है?
Angle can be negative. For example, if here the my this movement is in this direction, okay, so my resultant will be somewhere over here, and in that case, my orientation of this theta here, it was clockwise. So clockwise, we assume that it is positive, but in that case, it would have been counterclockwise. So here if I had substituted the angle tan theta, the theta would have been counterclockwise, and in that case, maybe I would have got a negative answer, and my orientation will be something like this in the counterclockwise direction. Did you get it?
Excuse me, sir.
Yes.
सर हम इसको शुरू से एक दफा रिकैप कर सकते हैं briefly?
Actually, I will do it again at the end because I know the video is not there.
Yes, sir.
I will do it at the end.
Thank you, sir.
Okay. Don't worry. Okay. So the next part was I have to compute maximum tensile stress and the compressive stress in the beam. Okay. So this is my cross section. Okay. And again, I am telling you again that this dimension is same as in the problem number 3. Okay. So this is my cross section with the dimension of, this dimension is 1 inch. This dimension is 8 inches. This dimension is 3.07 inch. This dimension is 3 inches. And this dimension will be 3 inches. Okay. So to find the maximum bending stresses, I have to use again this formula that we derived, mzy over iz plus my z over iy. Now you can visually look at this picture and you can figure it out that maximum bending stresses will be occur because for every case mz and my, iz and iy will remain the same. So these two factors will determine that where will be the maximum bending stresses will be occur. So the maximum value of these two values will govern the location of maximum bending stress. So the maximum value will occur first at this point, let's say, or at this point, or at this extreme, or these two extremes. Okay. So we will calculate, for example, let's name it at point A, B, C, and D. So we will calculate separately the bending stresses at 4 of these points separately, and we can see from the values or from absolute values that which is our maximum bending tensile stress and which is our maximum compressive stress. So let's first do it for point A.
एक्सक्यूज मी सर
Yes.
सर हमने पिछले पार्ट के लिए क्या चीज फाइंड की थी
What?
पिछले पार्ट ए के अंदर हमने क्या चीज फाइंड की है
We basically calculated the inclination of the neutral axis.
सही
In this one, we are calculating the.
सर हमें इस इंक्लिनेशन से नहीं पता चलता कि कौन के स्ट्रेसेस कहाँ पे मैक्सिमम है कहाँ पे नहीं है
What does this inclination? Actually, the inclination is just telling you that which is the axis or where is the axis at which the stresses are zero. It doesn't show you anything else. Okay. How can it tell me? Just try to think.
सर बिकॉज इनिशियली हम लोग ये ले रहे होते हैं ना कि ये कंसिडर कर रहे होते हैं कि लोड 90 डिग्रीज टू न्यूट्रल एक्सिस एक्ट कर रहा है तो डजंट दैट से कि मतलब 90 डिग्रीज पे ही जो है वो मैक्सिमम होगी जो स्ट्रेसेस होंगे वो मैक्सिमम होंगे अगर लोड 90 डिग्रीज टू न्यूट्रल एक्सिस एक्ट करेगी
So it means that if the load is acting on 90 degree to the neutral axis, it just shows two things: the orientation of the moment, and the second thing is it shows you that where is the neutral axis. So basically, the neutral axis is telling us that what is the orientation of the moment. So that orientation of the moment we utilize to calculate or to divide the moment on the principal axis. And now we will calculate the maximum bending stress. I don't think so. It doesn't show you that anything else. So let's say we have to calculate the bending stress at point A. So at point A, sigma is equal to, again I told you before that the direction of mz and my will depend on the axis where it is lying. So both of them are negative as we have calculated before. So it will remain negative 84. What is y distance for point A?
3.07.
Y distance is 3.07 and this sign will be positive or negative?
So it would be positive.
Yeah, it will be. And what is z distance?
So z distance would be 3.
Z is
3.
negative 3 because it is in the negative z direction. So this moment my we calculated before also, that is
Sir, my negative 84 नहीं था?
Yeah, mz is actually I put in the wrong convention. Mz is actually minus 182.34 and Iz is actually 112.6. Okay, and my is minus 84 and z distance is minus 3 inches and Iy is 18.7. Okay. Yeah. So can anyone give me the answer for stress at point A? Sigma A is equal to, what is the answer?
18.44.
18.45 with a positive sign or the negative sign?
Positive.
Positive sign. So that means that our stress at point A is tensile and the value is 18.45. Now, it may happen that the stress at point B, for example, is maximum or more than this A1, and we will calculate again for point B and see that what is our value. So let's do it for point
ये तो symmetric नहीं होता.
What?
ये तो symmetric figure नहीं है तो इसमें ज़्यादा और कम क्यों होगा?
As you can see also in this one, that first we are also taking the sign convention of these distances. For example, on this side, these signs will change. So it is quite possible that the positive will turn into negative. And physically, if I show you, like in this case, as you can see in this example also, that on the right hand, both of the forces that are acting in the section are not compressive or tensile. In the, for example, at the right hand, the compressive force is acting, and in this case also the compressive. So let's say they will both add up. But in this quadrant, as you can see, that the tensile stress is acting, but in this quadrant at this point, okay, the compressive stress is acting. So basically it is the algebraic difference in this quadrant. But now we have fixed the sign convention, as you can see. So our understanding is this, that if we move into this quadrant, our notation will change for these distances and we may get a different answer on the B point. So did you get my point?
Yes, sir.
Okay. So let's repeat the same exercise for point B, and what will you get? My MZ is minus 182.34. What is Y distance for point B?
3.07, sir.
3.07 and in the positive direction. So it will remain the same. This will also remain the same, 112.6. But here the sign is negative, plus minus 84, that is my My. And what is Z distance now?
Positive 3.
Positive 3. So what is my stress at point B? The stress at point B is equal to, can anyone give me the answer?
Minus 8.5.
Minus
8.5.
8.5. Actually, I don't have the answer for it, but I think it is 10. Can anyone else confirm it also?
8.56.
8.5. Okay, so I think that is the answer. So now you can see that at point B, I have the compressive stress that is acting, and the magnitude is minus 8.5. So at point A, I have the tensile stress. At point B, I have the compressive stress. So let's calculate the stress at point C now to see if I can get any maximum value for the compressive strength or maybe the tensile strength. Okay. So what will be my equation? All other things will remain the same. This will be minus 182.34. This will be, okay, the distance we can figure out later. And this will be also minus 84. This distance divided by 18.7. So what is my Y distance for point C? For point C, what is this distance? Anyone?
5.93.
5.93. And what is the Z distance?
4.93.
5 point. Actually,
4.93.
no. This is 3.07. So 9 minus 3.07. 5.93, I believe.
It's 5.9.
Yeah. So 5.93, and what is the Z distance from this point to this point? Actually, this one is also 1 inch. So the Z distance is 0.5 inch basically. So Z distance is in the positive Z direction, so it will be positive 0.5, and Y distance is in the negative direction, so it will be negative 5.93. Okay.
एक मिनट Z जो Z
Yeah.
डायरेक्शन है वो नेगेटिव 0.5 नहीं है.
Wait, let me show you. So what is Z direction? From this is my centroidal axis and this is my Z distance. So this is my C point. So it is in the positive direction. Okay. So what is my stress at point C?
Minus 11.85.
Minus 11.85. kilopounds per square inch. Compressive. So you can also do the similar exercise for point D, but I think you are going to get the less answer for this one because I have done it already. So from these calculation, you can finally say that your maximum tensile stress that is acting in this member is 18.45 KSI, and the maximum compressive stress, or I will name it as sigma T maximum, and sigma C maximum is equal to minus 11.45 KSI. So this is your final answer, that the stress, maximum tensile stress is 18.45 and maximum compressive strength is. So this is how you are going to solve the question for unsymmetrical bending of symmetrical section. So basically, this concludes our topic of unsymmetrical bending for the symmetrical section.
सर पार्ट ए का एक मिनट दिखाना जो आपने कैलकुलेट किया था इसके अंदर वाई डिस्टेंस हमने इनके लिए
Part A, by part A you mean point A?
सर पॉइंट ए
This y distance is 3.07.
सर लेकिन ये नेगेटिव किस लिए लिया
What?
ठीक है समझ आ गया
Yeah. So this
सर
basically.
एक बार रिवाइज करा दें.
Daniel, I will do it after this lecture. Don't worry, I will make a small video of the revision and I will upload it.
Thank you, sir.
Yeah. So this basically concludes our topic for unsymmetrical bending of symmetrical section, and we have mostly you are going to see similar kind of the problem. The only difference will be in the shape of the cross section that you are going to get, or the type of loading. For example, you may get, or maybe not, you won't be getting the UDL in these cases, but mostly the point loads, but you may get different kind of inclination over here, that where this load is acting. For example, the load can also act something like this one. So you have to be very careful while figuring out the direction of the resulting bending moment. Also, I will be posting one assignment for this topic. Actually, that assignment also covers the unsymmetrical bending of unsymmetrical sections, which we are going to discuss in the next couple of lectures. But I would suggest you to start solving that assignment, because most of the problems for symmetrical section are similar to the one that we have solved today, and you can solve them. So start solving for the symmetrical section, and you can keep on solving for the unsymmetrical after we will discuss that topic. So this concludes our lecture, and if you have any questions, you can ask me now.
सर ये मैक्सिमम स्ट्रेसेस निकालने के लिए हम हमेशा कॉर्नर पॉइंट्स लेंगे.
Actually, at the corner points, you are going to get the maximum distance, so you can try all the corner points, and in most of the cases, yeah, because either you are going to get the rectangular shape or I shape. So in all of these sections, you will get the maximum stresses at some corner point.
Okay.
Yeah. So any other questions?
सर डिस्टेंसेस की साइन कन्वेंशन बता दें, लाइक ये y z वगैरह की जो है.
Okay, for the distances, the thing is you just have to look at where does my point lies. For example, firstly we did for point A. So from the center or from the centroid, what is the y distance of point A? In this, we are going to use this equation. The y distance is in the positive y direction. My positive y direction is in the upward side, and the positive z direction is on the left side. So y distance is 3.07 and it is in the positive y-axis, so I will take it as positive. But now look at the z distance. Z distance is in the negative z quadrant, okay, because my positive direction is towards the left, so this is the negative one, so that's why I have put in the negative sign with the z distance. Okay, so let's look at point B. In point B, I have used 3.07, which is the y distance, because again, the y distance is this one for point B, and it is in the positive y-axis. And z distance is this one. Now it is also in the positive z-axis. So I have taken the positive sign with this z distance, as you can see here. Okay, so this is how you will finalize the sign for this distance. Any other question? Okay, if you have no questions, so this concludes our class, and I will make a brief video about the first part, so you can look at it again later if you want to. Okay, then we will, actually I will inform you about the lecture of tomorrow. We may not have a lecture tomorrow, and we will have a lecture on Thursday, but from now on we will be shifting towards the basic structure analysis. So this concludes our lecture, and thank you very much for your time. Allah Hafiz.